Okay, I'm going to talk about acids and bases here. So you got to know what a strong acid or a strong base is. The definition of strong is that it is 100% ionized. So if I put HCl in water, all of it breaks apart. Whoops. All of it breaks apart into ions, 100%. Okay? And so there are 7 strong acids, and you have to have these memorized. It's on your list of things to memorize for the summer assignment. And what you can assume is if it's not on this list, it's not strong. And there are hundreds of other acids that are not on this list, and they are all considered to be weak. Did I say strong? I meant to say weak. These are the strong ones. Everything else is weak. All right, so let's take a look. The following diagram represents aqueous solutions of 3 acids, HX, HY, and HZ, with water molecules omitted for clarity. Rank them from strongest to weakest. So if I look at, let's say HZ, for instance, this still is HZ. It's together like a molecule, okay? So same thing with HX. So the answer is HY because all of the molecules have come apart into ions. All right, strong bases, definition is 100% ionization, just like strong acids. Okay, so the strong bases are the hydroxides of group 1 and the larger group 3, or I'm sorry, group 2. So the group 2, it's the larger ions. It's the barium, strontium, and calcium, okay? So the hydroxides of these guys. So, for instance, sodium is sodium hydroxide. Barium is going to be BaOH2 because the hydroxide's a -1 charge, barium's a +2 charge. All right, so let's take a look. Classify each of the following dissolved substances as a strong electrolyte, weak electrolyte, or non-electrolyte. Okay, so if you remember, strong, I want you to answer these first, but strongs are soluble ionics, strong acids, strong bases. Okay, anything that's a molecule is going to be a non-electrolyte. Okay, and a weak is a weak acid or weak base. Okay, so CaCl2. That is an ionic compound and it is soluble, so that is going to be a strong electrolyte. Nitric acid, it's on the strong list, that's going to be a strong electrolyte. This is ethanol, okay? It is a molecule, it is going to be a non-electrolyte. Now this says it's an acid, and it's not on my strong list, so that's going to be a weak. Potassium hydroxide is a group 1 hydroxide, so that is going to be strong base, so it is strong. Write the net ionic equation for the following acid-base reactions. Okay, so this is acetic acid plus lithium hydroxide. They're going to swap partners. I'm going to end up with lithium acetate plus water, and water is going to be a liquid. These start as aqueous. Okay, now I have to make a decision of what to write as ions. Now remember, the only thing we write as ions are strong electrolytes. Acetic acid is a weak acid, so I do not ionize it. I write it as a molecule. Plus lithium plus hydroxide minus, because that's a strong base, right? This is a soluble ionic compound, so I write this as ions. Plus water. Okay, so if I look at what my spectators are, it's just the lithium. So here's my net ionic. It's going to give me the acetate ion plus water. Okay, the thing that students will do wrong is they will write this as ions. It's weak, so you leave it together. Hydrochloric acid plus ammonia. Okay, so I'm going to end up with NH4 plus Cl minus. Okay? So this is an H plus, this is a Cl minus because this is a strong acid, plus NH3. It's going to give me NH4 plus Cl minus. The only thing that's a spectator is a Cl minus, so I have H plus NH3 gives me NH4 plus. Okay. Hydrochloric acid and sodium hydroxide. They're going to swap partners. I'm going to end up with NaCl plus water. This is a strong acid, so I write it as ions. This is a strong base. I write it as ions. This is a soluble ionic compound. I write it as ions. This is a liquid. It's a molecule. Okay? So if I eliminate my spectators, I eliminate chlorine, sodium, and I'm left with H plus OH minus gives me H2O. And one of the things you'll notice after a while is that for a strong acid, strong base reaction, I always end up with this as my net ionic equation. Alright, we're going to stop right there.